Another type of a goodness of fit test is when the distribution that we're looking at is not a uniform distribution. So let's consider this example. It says a study was conducted to investigate racial disparity in clinical trials of cancer. Among the randomly selected participants, 644 were Caucasians, 23 were Hispanic, 69 were African American, 14 were Asian, and 2 were American Indian. So the proportion of the US population of the same groups are 75.7% Caucasian, 9.1% Hispanic, 10.8% African American, 3.8% Asian, and 0.7% American Indian. So now the question is, does our sample represent the population? Are the proportion in the sample the same as the proportion in the population, or was there bias in how they selected participants in that study? So let's take a look at this problem together. So here, I already started filling out this table. For my observed values, I transferred the numbers that they gave us into the first row for the observed values. I also calculated the total of this group, and I came up with 752, which is our N, our sample size. Now, if your population is not uniform, but you have percentages for each category, what you would do, you would take the total and multiply the total by the percentage for that group to get your expected value. So, for example, the expected frequency for Caucasians would be 75.7% of this total. So we're going to take that number total of 752 multiplied by the percentage 0.757. That would give us 569.264. So I'm going to round it to a whole number. So our expected number for Caucasian would be 569. So we see that in actuality, that number was higher. So we already get suspicious, but the question is, did it happen by chance, by a natural fluctuation, or was it design? Okay, so I'm going to continue this whole process to find expected values for the other categories. So here are the numbers that I got. Now, for your null hypothesis, you're going to say the frequencies in a sample conform to the frequencies in the population. So that's going to be your null hypotheses. Okay, there we go. Okay, and for the alternative, you're going to say that at least one frequency is not as stated. All right, so now that we have set up our null and alternative hypotheses and our expected values, the next step is to figure out the significance level. Well, the significance level is always given to you. So in this case, it's 0.05. Now we need to find our test statistic. And the formula for the test statistic is the same as in the previous problem. It is the sum of all of the residuals from each category. The difference between the previous problem is that our expected value is going to change for each category. So we're no longer going to have the same denominator. So the calculations are a little bit complicated, but not much. So I'm going to write the first one with you. So that's observed is 644. The expected is 569. Find the difference square and divide by 569. I'm going to continue that for each category. There you go. And after we put this whole thing into a calculator, we're going to get 51.00157,473. So, and I'm going to round this value to 3 decimals. So 51.002 is my test statistic. Now let's figure out what's the p-value that corresponds to the test statistic. And I want you to think about what are we going to use for the degree of freedom? So in my problem, we had 5 categories. So the degree of freedom will be 4. I put in our test statistic and the right tail test, right? So change the sign here. And this is the result that I got. The e to the negative 10 right there, it's actually a scientific notation. So that means that it's a very, very small number. All right, so this is what we got using the StuckWrench, the p-value that we got. Let's break it down, what that means. That means move the decimal point 10 places to the left. This is 10 times 10 to the negative 10, actually. So let me write it down so that it's times 10 to the negative 10. That's how you read that. And this means you're going to move your decimal place 10 times. So I have 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2, 2, 3, 0, 1. So as you can see, this is a very, very, very small p-value. So the probability of this difference happening without a design is actually minuscule, like non-existent. Okay, so what do we conclude here? Well, since our p-value is less than alpha, we're gonna reject the null and accept the alternative. And what does the alternative, what does the null say? The null say that the frequencies in the sample conform to the frequency in the population. We rejected that statement. So that would mean that it's the frequency in the samples are different, right? So what would you say? Is there a racial disparity or discrimination going on here? What's your conclusion? We have enough evidence to suggest that the distribution of study participants does not fit the distribution of the population, and therefore the claims about racial disparity are valid. All right, so that's the end of this example, and I'll see you in the next one.